Good morning everyone. Welcome to Narayana online video classes. Today for class 8 students under the topic trigonometry we are going to study trigonometric ratios of 270 degrees minus a, 270 degrees plus a, 360 degrees minus a. In previous class we have seen sine of trigonometric ratios and also 90 plus a, trigonometric ratios of 90 plus a, 180 minus a, 180 plus a we have observed. Today in our class we are going to see trigonometric ratios of 270 minus a, 270 degrees plus a and 360 minus a degrees. Okay. While explaining sine of sine of trigonometric ratios, yesterday I explained you like if you have an angle of the form n times of 90 plus or minus theta, if n is even then sine changes to be, sine remains as sine only. There is no change in sine function. Cos remains as cos if n is even. Similarly, if n is odd, the trigonometric ratio sine changes to cos, cos changes to sine, tan changes to cot, cot to tan, cosecant to secant and secant to cosecant. Okay, that is very important point, first point to note. Next, we have seen in first quadrant, that is theta between 0 and 90 degrees, all trigonometric ratios are positive. In second quadrant where theta is in between 90 and 180 degrees, we have seen sine and cosecant positive. If you take the third quadrant where theta lies between 180 and 270 degrees, tan and cot are positive. If you take the fourth quadrant where theta lies between 270 and 360 degrees, 270 degrees and 360 degrees, we have seen cos as well as secant positive. Now, based on that, here we will see what is sine 270 degrees minus a, what is cos, what is tan, what is cos secant as well as cot of 270 degrees minus a. If you look at 270 degrees minus a, it is in the form of 3 times of 90, odd multiple of 90. So sine changes to cos. If you take 270 degrees minus a, that is an angle in third quadrant where sine is negative. So we have minus cos a. Similarly, cos 270 degrees minus a, cos changes to sine. Same way cos is not present in third quadrant, so again we will have minus sine. Tan 270 minus a, 270 means 3 times of 90, so tan changes to cot, but the sign is positive because quadrant tan and cot are present. Okay, now for the rest of, only for tan and cot we have got the sign as positive, rest of the trigonometric ratios the result is minus. This is the first observation. Next, if we take 270 degrees plus a, 270 degrees plus a is the angle in quadrant 4. Okay, 270 is again odd multiple of 90. So sine changes to cos, cos changes to sine, tan to cot, cot to tan, cosecant to secant, secant to cosecant. That is first observation. Next, about sines. In the fourth quadrant, cos and secant are positive. So only their constant ratios will be positive. Rest of the ratios are negative. That is second observation. Now the third one, if you take 360 degrees minus a, 360 degrees minus a is an angle in quadrant 4 again, and 360 is even multiple of 90. So what do you mean by that? Sine changes to sine. Is it there is no change? In fact, sine is written as sine again, cos as cos, tan as tan, cot as cot. The same trigonometric ratio remains. Only the changes in signs are observed. Here in quadrant 4, as we have discussed earlier, cos and secant are present there. So their constant ratios will be positive. Rest of the values will be negative. So here cos as well as secant both are positive. Rest of the values are negative. Okay, minus sine, minus tan, minus cosecant, minus c. Okay, this is how we can minus cot. We can observe like that. So this is about 270 degrees minus a, 270 degrees plus a, 360 degrees minus a. Okay, now we move to the next concept. Suppose you have 360 degrees plus a, what to do? 360 degrees plus a or any multiple of, any integral multiple of 360 degrees plus a always lies in quadrant 1. This is all belonging to quadrant 1, where if a is an acute angle, so 360 plus a, n times of 360 plus a always belong to quadrant 1, just like angle a. Because if a circle completes one rotation, obviously the angle made is 360 degrees. Okay, any number of rotations you make, complete rotation if you make, for every revolution what I can call, we have 360 multiples angles. So n times 360 plus theta or n times 360 plus a always equivalent to a. Keeping that in mind, we see that A 360 plus A as well as n times of 360 degrees plus A always lies in first quadrant. So what all the concepts in first quadrant? All are positive. The same thing applies even for 360 degrees plus A or n times of 360 degrees plus A. Similarly, if you have 360 degrees minus A, we have observed that it is in quadrant 4, it belongs to quadrant 4. Now n times of 360 degrees minus A also belong to quadrant 4. Similarly, minus A also an angle in quadrant 4 if A is an acute angle. This is another thing. Next, if you have n times of 180, n times of 180 here, if it is even, it comes under 360. If it is odd multiple of 180, if it is odd multiple of 180 plus theta, it belongs to quadrant number. If n is odd multiple of 180 plus theta, it lies in quadrant 3. n into 180 degrees minus theta, if it is odd multiple, then it belongs to quadrant 2. These are the observations, very, very important points to note. If you have 360 degrees plus A or any integral multiple of 360 plus A, that lies in quadrant 1. Next, 360 minus A, it is quadrant 4. n into 360 degrees minus A also in quadrant 4. Even minus A is in quadrant 4 if A is an acute angle. Next, if you have n into 180 plus theta, if n is even, the same discussion as that of these two. So we have to talk about n odd. N odd into odd multiple of 180 degrees plus theta, then it belongs to quadrant 3. If n is odd and odd multiple of 180 degrees minus theta, it lies in quadrant 2. This is another point we have to keep in mind. Now, based on this, we are going to solve few problems. The first one is, what is the value of cos 420 degrees? It's a simple question. What is the value of cos 420 degrees? Cos 420, which is more than 360 degrees. So whenever you are given such angles, you have to see its nearest multiple of 360. So its nearest multiple of 360 is 360 itself. So we can write it as cos 360 degrees plus 60 degrees. If it is cos 360 degrees plus theta, it is same as that of cos 60 degrees. So that it is cos 60 degrees. We know the value of cos 60 degrees, that is 1 by 2. Next, if it is, this is the first thing. If you are asked to find out what is the value of cos 585 degrees. Cos 585. Here, rather than 360, I better go for 180 multiple, because 540 degrees plus 45 is nothing but 585 degrees. 540 is 3 times of 180. Okay, so if I convert this as cos 3 times of 180 degrees plus 45 degrees, the discussion will be very easy. It is odd multiple of 180 degrees plus theta, so it lies in quadrant 3. As it is in quadrant 3, this is minus, again 180 multiple, so that it is cos 45 degrees itself. So minus cos 45, that is minus 1 by root 2. Okay, next. Okay, now let us take cot 1140 degrees. 1140 degrees, if you look at this, it is nearest to 3 times of 360. 3 times of 360 degrees is nothing but 1080 degrees. So plus 60 if you do, that is going to be 1140 degrees. That is again cot n times of 360 degrees. N is an integer, n times of 360 plus theta is an angle in first quadrant. So simply it can be equivalent to cot 60 degrees. Cot 60 degrees value we have already. It is 1 by root 3. Okay. Now next, we'll move to the next question. See, here very important point. Suppose you have, sometimes you'll ask, what is the value of 1 minus cos square theta into cosecant theta? Okay. There is a question, root over 1 minus cos square theta into cosecant theta. What is the value of this? There is a lot of confusion in this particular question. Root over 1 minus cos square theta, generally what do you write? We'll write it as sin theta. Cosecant theta is 1 by sin theta. So sin theta cancels. The answer is 1. Is it true always? Definitely not. It is plus 1 as well as minus 1, depending on theta value. Okay. So how to solve these kind of problems? Root over 1 minus cos square theta, in fact we have to write as root over sin square theta, of course, right? So that is nothing but mod sin theta. This is very, very important. Mod sin theta we have to write into cosecant theta is of course 1 by sin theta. What is the meaning of mod sin theta? Whatever theta you take, whatever input you take, resultant must be positive. That is a idea about it, idea behind writing absolute value, right? Now, if theta is in quadrant 1 or quadrant 2, if theta is the value in quadrant 1 or quadrant 2, means if theta lies between 0 and 180 degrees, if it is between 0 and 180 degrees, what you can say, we can simply write it as sin theta into 1 by sin theta, that is going to be 1. Okay, this is for theta in 0 degrees and 180 degrees. Of course, that is true for even 0 degrees we cannot take because cosecant is not defined there. Okay, 180 also we cannot take because cosecant is not defined there. So it is better to take theta in between 0 degrees and 180 degrees. Why I am taking this as plus 1? If theta is in between 0 degrees and 180 degrees, sin theta is always positive. Again here also sin theta is positive. So the resultant is mod sin theta, we can write as sin theta, because mod sin theta intention is to give a positive answer. So sin theta is of course positive. So mod sin theta we can write as sin theta directly. In that case the result is 1. In case if theta is belonging to quadrant 3 or quadrant 4, then we know that it lies between 180 degrees and 360 degrees. In that case, mod sin theta becomes minus sin theta into 1 by sin theta. That is going to be minus 1. So this is very, very important point. Depending on theta, where it lies, the result will be either plus 1 or minus 1. So we must be little cautious while solving this kind of problems. We will take an example. If you take, find the value of root over 1 minus cos square 250 degrees into cosecant 250 degrees. Just like earlier, that is equal to. So what to write there? Mod sin 215 degrees into 1 by sin 250 degrees. Sin 215 degrees, 215 degrees is an angle more than 180. Less than 360, it lies in 180 to 360 range. So definitely sin is going to be negative. So what to write there? To make it positive, we have to write it as minus 250 degrees into 1 by sin 215 degrees. Because sin 215 is already minus, so minus of minus is only becoming plus. So the purpose of modulus is resolved, justified. So that we have to write minus sin 215 here. So the answer becomes minus 1. Here plus 1 won't come because it is 215 degrees is the angle in quadrant 3. Okay, now this is how we have to solve this problem. Now we'll move to the next problem. The problem is, if A, B, C are angles of a triangle, I better write the question here. If A comma B comma C are angles of a triangle, ABC, then cos of 3A plus 2B plus C by 2 plus cos A minus C by 2 is dash. What is the value of this? Okay, if you look at this solution, let us take, let me take 3A plus 2B plus C by 2. I can write it as 2 times of A plus B plus C plus A minus C by 2. Okay, I am just regrouping. 3A plus 2B plus C I am writing as 2 of A plus B plus C plus A minus C by 2. That is otherwise 2 of A plus B plus C. 2 to cancel, simply we can write it as A plus B plus C plus A minus C by 2. What is A plus B plus C? Because ABC are angles of a triangle, obviously A plus B plus C is equal to 180 degrees. So this is obviously 180 degrees minus of A minus C by 2. Now, let us take the problem. Therefore, cos 3A plus 2B plus C by 2 plus cos A minus C by 2 is going to be cos of 3A plus 2B plus C by 2. Just now we have proved it is equivalent to 180 degrees minus A minus C by 2. Okay, plus cos A minus C by 2. That is equal to cos 180 minus theta. Cos 180 minus theta is obviously minus cos theta. So we have minus cos of A minus C by 2 plus cos of A minus C by 2. So both are equal in magnitude but opposite signs. So the answer is 0. Okay. Now we'll move to the next problem. The problem is, find the value of cos theta plus cos pi plus theta plus cos 2 pi plus theta plus cos 3 pi plus theta so on plus cos 20 pi plus theta. Okay, this is the question. Let me regroup. Let us take these two as a group, these two as a group, and here before that we have few more terms. Anyway, now if you take cos theta plus cos pi plus theta, cos pi is running for 180 degrees, pi radians is equal to 180 degrees, cos 180 degrees plus theta is minus cos theta. So cos theta plus cos 180 minus 180 plus theta as minus cos theta. If you write, this will be cos theta minus cos theta plus cos 2 pi plus theta is of course cos theta. Here cos 3 pi plus theta. 3 pi plus theta, as I told you, odd multiple of pi plus theta lies in quadrant 3. Again cos is negative there, so minus cos theta plus so on plus. If you look at that, even odd combination is always giving you cos theta minus theta, which is of course 0. So here also let us write here cos 18 pi plus theta plus cos 19 pi plus theta plus cos 20 pi plus theta. Let us write like that. Plus cos 20 pi plus theta. Cos 20 pi plus theta. That is going to be, see, if you look at this, this is 0, this is 0, and here also cos 18 pi plus theta. 18 pi plus theta is nothing but, that is even multiple of 2 pi we can say, that is cos theta, cos 19 pi plus theta, odd multiple of pi plus theta, quadrant 3 it is minus cos theta. So here also it is a combination of cos theta minus cos theta. So all will become, this will become 0, this will become 0, even this will become 0. Only we are left with 0 plus so on plus 0 plus. It is only cos 20 pi plus theta. 20 pi plus theta is nothing but even multiple of 2 pi plus theta, that is equivalent to cos theta. So the final answer is cos theta for us. Okay, that can be written as 1 by secant theta, whatever, according to the options we can answer it. So here what is important, regrouping is very important, and one more thing, cos even multiple of pi plus theta is in first quadrant, cos odd multiple of pi plus theta is in quadrant 3. If it is in quadrant 1, it is plus cos theta. If it is in quadrant, it is minus cos theta. That is the point we have to keep in mind. Okay, now we will move to the next problem. The problem is x tan square 120 degrees plus 4 into cos square 150 degrees is equal to 9, then find x. Okay, it's a simple question. Solution, let us take x into tan square 120 degrees is nothing but tan 120 degrees whole square. Tan 120 degrees is nothing but tan 90 degrees plus 30 degrees whole square plus 4 times cos 150. So that is cos 90 degrees plus 60 degrees whole square, that is equal to 9. It can be even 180 degrees minus 30 also, your wish. It is also 180 minus 60, you can write in any way. That is equal, that implies x times tan 90 degrees plus theta. 90, even odd multiple of 90 means tan changes to cot. So cot 30. Is it plus or minus? As 90 plus theta is in second quadrant, it is minus. So minus cot 30 degrees whole square plus 4 into, here also the same thing, 90 means cos changes to sine, and cos second quadrant angle cos of that is minus sine, minus sine of 60 degrees whole square, that is 9. That implies cot 30 is root 3. So that is 3x plus 4 into sine 60, that is 3 upon 4. That is equal to 9. Okay, sine 60 degrees, of course we have minus sign, of course sine power is even, so minus will be waived off. Sine 60 degrees is root 3 by 2, so it is 3 root 3 square, that is 3 by 2 square is 4. So 4 cancels anyway. That implies 3x is going to be, if you transpose it to the other side, 9 minus 3 becomes 6. It implies x is equal to 2. So the answer for x is 2. That is how we have to solve this kind of problems. Okay, that's it. Thank you.